So in this session we're going to talk about EtherChannel. EtherChannel. So let's see what EtherChannel is. It's a technology or a protocol. Well, obviously EtherChannel is a technology. So let's see what it is. What the definition of EtherChannel is. EtherChannel is a port link aggregation technology. It's a port link aggregation technology or port channels architecture used primarily on Cisco switches. Okay. It allows grouping of several physical Ethernet links to create one logical Ethernet link for the purpose of providing fault tolerance and high-speed links between switches, routers, and servers. An Ether channel can be created from between 2 and 8 active fast gigabit or 10 gigabit Ethernet ports. So the main thing here to look and to emphasize on is grouping of several physical Ethernet links to create one logical Ethernet link. Now, out of the blue, why should we use this technology? That should be everyone's question. Now, EtherChannel is really a part of the topic is a part of another topic, so it's a subtopic of spanning tree protocol. Okay, now I'm going to tell you very briefly about spanning tree. Now, seeing these amber colored lights or the orange colored lights, now one of the link has green light, okay, and the other two has amber or orange colored lights. What this means? This means that the other two links connecting switch 1 to switch 2, okay, connecting switch 1 and connecting switch 2, they are in a block stage. Okay, block stage. This is because suppose this is the switch 1 and this is switch 2, suppose, okay, and I have connected 4 links over here. Okay, now STP says that it will allow only one link to function and the other 3 will not function. The reason is that if this link also works, I mean first one also and the second one also, both the links are working, and what happens is that if data is forwarded from 2 to 1 from this port, and again the data can be forwarded from this port to this port, so there will be a broadcast flooding. Okay, so it will be unicast flooding. Okay, so this will create a huge overhead of CPU. The CPU processing will, I mean the capacity of the CPU will is always limited, so it will reach the highest capacity. So for that reason the rest of the links will be in block stage. Okay, so EtherChannel, now EtherChannel is really a part of STP. Now you know the brief knowledge about STP, and EtherChannel always will bundle. It's the bundling or grouping of several physical Ethernet links to create one logical Ethernet link. So suppose, you know, this is the switch 1 and this is switch 2. Okay, from outside we are connecting multiple links. Okay, so 3 physical links we are connecting, and by configuring EtherChannel, we will make these into only one logical link. So basically there are 3 links. Okay, basically physically there are 3 links, but by configuring EtherChannel we are making it only one logical link. That's why it is called bundling of physical links to provide only one logical link. I hope this is clear. Okay. Now this diagram will make you understand a little bit more, because let's see, this is the physical topology and this is the logical topology. So this is the link that we're connecting physically, and after configuring ether channel, this is the result. Okay, so this is the logical link, and always remember that STP works in the logical link, not on the physical link. Okay, logical link. STP is a spanning tree protocol. Which we will study in the next session. I mean, the next topic of our discussion will be STP, but before that we will be completing ether channel and the lab portion of ether channel. Okay. Ether channel makes two or more physical links into one logical link. So there may be two, there may be three, there may be four physical links connected, and we can always configure them into one logical link. Okay. Now let's see about the configuration modes. Just like we had it in DTP, we also have here. Okay, ether channel can be configured in two different ways. One is manual configuration and the other is negotiation protocol. Okay, now generally both are used. Okay, but using negotiation protocol, this method is preferred. Okay, there are two Ethernet negotiation protocol. So negotiation protocol, there are two types of negotiation protocol. One is PAGP or port aggregation protocol, and the other is LACP, that is link aggregation control protocol. Now between these two, LACP will always be preferred because LACP is an open standard ether channel negotiation protocol, and PAGP is Cisco proprietary. So what these two terms mean is that PAGP can be configured only on Cisco. PAGP only on Cisco. PAGP only Cisco. LACP every other. It's wrong to say other, but each and every switch. Okay. Each and every switch. It can be a Cisco switch, it can be a Juniper switch, anything. Open vendor. Okay, open standard, any vendor. So that's why LACP will be preferred over PAGP. So this was about the negotiation protocol. Now what about the types of negotiation? Okay, just like we had studied in DTP, like it had dynamic, desirable and dynamic auto. PAGP also has two different modes, desirable and auto. Okay, now the desirable portion can initiate the negotiation and the auto portion can listen or reply to the negotiation, just like we had it in DTP. Okay, similar to DTP. I like DTP. Okay, desirable initiates the negotiation and auto listens to the negotiation. And LACP also has two different modes, active and passive. Here active can initiate the negotiation and passive can reply or listen to the negotiation. So active can be compared to desirable and passive can be compared to auto. Okay, now let's look at the mode compatibility. Okay, now manual configuration, there you can always go and configure it manually. Okay, so manual configuration, there is no negotiation or listening like that. It's just manually you go and configure. So we will see that in our lab session. Okay, so there the different compatibility of modes there are. If suppose it's switch 1 and then switch 2. Okay, and switch 1 and switch 2. Suppose switch 1 you have gone and configured it in the manual configuration mode, so in the other switch you also have to do it manually, because it's manual should always be compatible with manual. It cannot get compatible with the negotiation protocols. Okay, no protocol will ever support the other switches manual configuration. So manual has to always go with manual. And second one is desirable auto. So auto will never match. Just think like that. When we were doing trunking and access, auto meant for access mode. Okay, just like dynamic desirable and dynamic desirable meant for trunking. Here also desirable will be a compatible mode, and desirable auto, just like in DTP, will also make for a compatible mode. So substitute the trunking compatibility for DTP for switching and for access and trunk ports for over here. So in DTP we saw that desirable and desirable will be a trunk port, desirable auto will also be a trunk port. So trunk ports and trunk ports, and here also we see that if we are using the negotiation protocol, desirable and desirable auto will be compatible, not also auto. Okay, the next is active and active passive. Similarly, just now I said that compare you can compare active to desirable and passive to auto. So active and passive will also be compatible. So 2, 3 and 4, 5 are generally similar, just because the protocol is different, so the modes are different here. Now configuration is very simple. Okay, you go inside the interface, because suppose it's I interface fast Ethernet 0/1. Okay, and then you write the command channel group 1 or 2 or 3 or 5 or 6, or and then mode will be this would be this would make sure which protocol you're using. If you give mode as active, then obviously you have to use LSCP, and if you give suppose auto, okay, you have to give PAGP. I have just used this example just to make you understand. Okay, so this is how you configure. We will be learning the configuration in the lab portion, so there's nothing to worry about. And one other detail about EtherChannel is that it's also known by these 4 names. One is port channel, the other is channeling, the other is link aggregation, and nick teaming. This is exclusive to the server side. Suppose a switch is connected to a server. Okay, there you go and apply this technology, nick teaming. So I hope Ether channel is more or less clear, because it will be clearer when we visit the lab. Okay, so I think let's revise. The main problem that results from this solution, the main solution of ether channel is due to the fact that, suppose this is a trunk link. Okay, this is switch 1 and this is switch 2. We have the end users over here, 3 hosts. Okay, suppose these are okay, fast Ethernet. Suppose these are 100 Mbps links. Okay, 100 Mbps. So all total, this is 300 Mbps links, and okay, this is all total is 300 Mbps, and there is one trunk link. This is 100 Mbps. So what happens is, suppose simultaneously all the 3 computers send data to this switch, and now this switch is receiving the data at a rate of 300 Mbps, and is sending to this switch at a rate of 100 Mbps. So obviously the rate at which it is receiving is more than the rate at which it is sending. So the data that it is sending is at a slower rate. Okay, and also the data at which it will receive from this switch will also be at 100 Mbps, so it will also be at a slower rate. And then when it will give out, it will also be at a slower rate, because the speed is 100 Mbps. So the link speed is 100 Mbps, and the data and the rate at which the data is coming to the switch is more than that. So for that reason, for that reason only, this technology was used. We are using this technology for that purpose, to efficiently to improve the efficiency of the layer 2 switching. Okay, now suppose I am connecting two extra physical link, and I am bundling it into one logical link. So now what will happen? Now it will receive and send data at an equal rate. Okay, 300 Mbps, and then 100 Mbps, 100 Mbps, 300 Mbps. So this is what EtherChannel does. Okay, now we will visit the lab session in our next video. So this was it. This is all about EtherChannel. Okay.